Hello everyone, welcome back to my YouTube channel, and today we are going to start the second lecture of this lecture series, full course of electric vehicle. And friends, if you attend the last session, means the first lecture of this series, so we have gone through with the what is exactly electric vehicle, the important parts, including mechanical and electrical parts, and we covered the types of electric vehicle, degree of hybridization, what is the hybrid vehicles and all. And today's session is basically dedicated to the battery system of electric vehicle. Friends, battery is the one of the most essential part of electric vehicle. So we decided to finish it from the basics to the advanced level, and the knowledge of basic of battery is very much important in order to make it better. So let's start it. And if you haven't watched the first video, I will add the description link of the video so you can watch it. So let us move ahead. So basically the battery or cells is the part of electrochemistry, and electrochemistry is the branch of science which deals with the interaction between electrical energy and the chemical energy. And friends, there are only two kind of interaction. First one is what? Conversion of electrical energy into the chemical energy, and second one is basically the conversion of chemical energy into electrical energy. And this the second type is what we are going to cover it in terms of battery. Okay. So let us understand the other substance which are responsible for the flow of electrons. So in order to understand, let us go ahead with the electrical conductors. So electrical conductors are substance which allows the electric current through it. For an example, you can consider metal, graphite, fused salt, aqueous solution of the acid bases, and salts. And we have two types of conductors. First one is electronic conductors, and second one is electrolytic conductors, which we are going to study. The electrolytic conductors. And the non-conductors, for an example, which we call the insulators, the substance which does not allows the electric current pass through it. So that is, for example, you can consider the rubber, you can consider the paper, dry wood, etc. Now let us understand the metallic conductors. What are the metallic conductors? Metallic conductors conduct electricity due to the movement of electrons from one end to another end. And in a solid, the electrical conduction involves the free movement of electrons, and in a metallic lattice, and without any movement of the lattice atom, this type of conduction is called the metallic conduction. And the metallic conductors, the electricity is carried by the electrons, and the atomic nuclei remaining is stationary. We need to understand, suppose this is what? Atom. So nucleus is somewhere at the center of this atom, other part is what? The space, a vacant there, and the electrons are at the outer orbital of this atom. So entire atom is not moving for the conduction of electricity, only and only the electrons are moving. So that's why we are calling the nucleus is what? Is stationary. Okay. So conductors we can call a good conductor, which conduct the maximum electrons from point A to point B, and semiconductors, those who partially conduct the electrons, electricity I will say, and non-conductors are insulator, those who did not conduct the electrons. So for an example, good conductors we can consider the metals like copper, aluminum, iron, silver, gold. They are called the good conductors. And wires are made up of aluminum and coppers, so that's why. And semiconductors, here you can see the semiconductors are very much important on point of view. If you are looking for a power electronics or electronics, complete electronics is based on the semiconductors. So in electric vehicles currently the use of electronics is very much high, so power semiconductors are important to understand. They are playing very important and major role in a electric vehicle controller. So semiconductors are substance which partially conduct the electricity. For an example, you can consider silicon and germanium. And the next one, we are going to cover the electrolytic conductors. So from here, the basic of battery is going to start. Let us understand substances in their fused form or aqueous form allows the passes of current undergoing a simultaneous chemical transformation or chemical reaction is called the electrolytes, and the conduction is basically called the electrolytic conduction and electrolytic conductance. So we need to understand the term what is meaning of conductance, and we already know about the resistance. So what is exactly the resistance? We are writing R is equal to what, V upon I. That means the obstacle in flow of electricity, and obviously the conductance is the reciprocal of the resistance. It has opposite nature of the resistance, so we are calling reciprocal of resistance is called the conductance, and we are writing C is equal to 1 by R, because the unit of resistance is what, ohm, because this equation is derived by the scientist named the Ohm, and the reverse reciprocal of the resistance is what, the conductance. So unit is what, ohm inverse. You can write ohm inverse, or simply you can write MHO, mho. And this resistance is depend on several more factors like the length of the conductor, area of the conductor. So we are writing R is equal to, we are writing rho L upon, and rho is nothing but that is the resistivity. Let's move ahead. Now understand what are the basic differences between the metallic and electrolytic conductors. So the metallic conductor conductance is possible due to the flow of electrons, while in electrolytic conductors the conductance is due to the movement of the ion in a solution. And this is the possible way for the making of batteries or cells, and it does not result any chemical changes, but this is possible due to the chemical reactions only. And the metallic conduction decrease with increase in temperature, while the electrolytic conduction increase with increase in temperature, because temperature increases the distance between the molecules, and they are free to more free to move. Ions are freely can move, and it does not involve any transfer of matter, but it involves the transfer of matter. For an example, आपको अगर ध्यान हो, सो जब हम लोग बैटरी इस्तेमाल करते थे टीवी देखने के लिए, तो बैटरी के जो दोनों इलेक्ट्रोड होते थे, काइंड ऑफ, सपोज दिस वन इज अ complete battery from here to here, and this one is what, suppose two electrodes are there. So electrode this one and electrode this one. So suppose this one is positive and negative terminal. So electrons are moving from this place to this place. So region is behind because they are continuously depositing here at this plate. So the length of this electrode is increased, and while the length of this electrode is decreased, because this is happening because of the transfer of the matter only. I hope you understand this. Let's move ahead. The next part is what is the specific conductance. So let us understand specific conductance is the conductance of all the ions that are present in 1 ml of solution, and we are writing it K is equal to L divided by S into 1 by R, or you can write K is equal to L by S into R. Okay, so that is what the specific conductance mean, and unit we will definitely write ohm inverse and centimeter inverse. And what is the equivalent conductance? Equivalent conductance is the conductance of total ion present in the solution containing 1 gram equivalent of electrolyte. So we can write this equation. Sometimes, why I am telling you in a very fast forward manner, because sometimes we require to calculate all these things, so we should know. Either if you want to learn exactly what is battery and battery pack modeling and BMS, that will come into the next lectures, and today's lecture is basically focused on the complete fundamental of this battery system and all. So molar conductance is the conductance of all ions of 1 mole electrolyte present in a solution. So this is 1 mole molar solution. So represented by the mu, and mu is equal to K into 1000 by capital M. So we need to remember this. Let us understand what is exactly the dilution. Dilution means adding of substance into that. So generally the conductance depend upon 3 factors. First one is the number of ions. Obviously if ions will be higher, so conductance also will be higher. And charge of ions. So charged particles are basically called ions. So if ion having a higher charge, so that can move, and mobility of ion, it is also very much important, because that because of mobility of ion only the current is producing. So as the dilution increase more, the electrolyte ionize more and the specific conductance decreases, absolutely, and the equivalent molar conductance increase with the dilution. So these are the some basic terms which we are learning, and in next section let us understand the electromotive force. This is very much important in terms of cell and battery. So electromotive force is the difference of potential which causes the current to flow from an electrode at higher potential to the one at lower. So because the battery is what, it is the setup of like this. Suppose these are the 2 electrodes and separator is there. So we are connecting it with the load. Suppose load is emitter, and because of the conduction of electron, this one is suppose it is 0 potential, and this one is suppose this 6 volt, 0 volt and 6 volts. So electron will flow from this side to this side. So the difference between, suppose this one is E right, I am writing, this one is E left, I am writing. So we will write the EMF of cell is equal to what? E right minus E left, just for an example. And let's move ahead. Application of electromotive force measurement. This is what potentiometric titration can be carried out with the help of EMF. Transport number of ions can be determined, and pH can be measured, and hydrolysis constant can be determined, and solubility of springly soluble salt can be found. So it is helpful in titration, it is helpful in the finding the transport number, it is helpful in the measuring the pH value, it is also helpful to finding the hydrolysis constant, and also it is helpful for finding the solubility of sparingly soluble salts. And now let us understand the galvanic cell. That is basically the fundamental of battery, fundamental of cell. So the knowledge of this part is very much important. Even though we have learnt about this in our 10th standard or 12th standard, or in I think one subject of chemistry is there in graduation also for the student those who are doing BTech. So in basic chemistry we are learning this one also. What is exactly the galvanic cell? So galvanic cell is what we convert the chemical energy into the electrical energy. Simple, that is the galvanic cell. And in which we have, see, the containers here containing the copper sulfate solution, and this is containing the zinc sulfate solution, and this one is called the salt bridge, which is we are using it to the balance of electrons, balance of reaction. And this one, this is what cathode, one electrode is there, one electrode is there. This one is called zinc electrode, this is what the zinc electrode, and while this one is what the copper electrode, written here already. And we are connecting it with the help of voltmeter here to measuring the how much voltage it is producing here after the connection, and it is also acting as a load. So this is what the working on the principle of half shell, means one is what anodic half shell, other one is what cathodic half shell. So at anodic half shell oxidation is take place, and while at cathodic the reduction is placed. I know you are aware about what is exactly the oxidation and reduction. So this is what the loss of electron and gain of electron. So what will happen if electron is moving from this side to this side? If the electron is losing here, and here you can see the 2 electron is what, the zinc sulfate is losing 2 electrons from here. So electron will move, just a minute, थोड़ा इधर ज़्यादा भीड़ हो गया है. Just a minute. So we can see here that if Zn is what, ready to lose the 2 electrons, that electron will start traveling from here to here and will deposit at this place. So electron is moving from this place to this place, that is what the oxidation means here at this place, and reduction is going to take place at this place. So because of movement of electron, the electricity is flowing from one side to another side. Okay, so this is very simple to understand. Now you can understand the reaction as well. Oxidation, that is what the D electronation is also called. So Zn is converting into the Zn2 plus, and 2 electron is releasing. At cathode, copper ion is taking 2 electrons and becoming a copper. So reduction is take place at the cathode, and oxidation is take place at the anode. And when we are writing the overall reaction, you can see here, so Zn plus Cu2 plus, we are adding this one to this one, Zn plus Cu2 plus is equal to what? Zn2 plus, and 2 in overall reaction this will be cancel out. So we are writing Zn2 plus and Cu. Got it everyone? Let us move ahead. So galvanic cell, we are representing it something like this. You can see here, we can write Zn SO4 and Cu SO4 Cu. Now, what is the reference electrode? The question asked in some time interviews, what do you understand by reference electrodes? So when an electrode of known potential is called the reference electrode. If we have cathode and anode, and if we know the potential of any one side, so that particular electrode is what the reference. The hydrogen electrode is the earliest primary reference electrode. The secondary references electrode discussed here. What is your calomel electrode and twin hadron electrode? So these are basically the reference electrodes. So what are the types of electrodes we are using, and what they exist exactly? The standard hydrogen electrode that we are calling is SHE, and it is the primary reference electrode, and the EMF of such cell arbitrarily been fixed as a 0. And it consists of a small platinum electrode coated with the platinum black, immersed in a 1m solution of H plus ion, and maintained at 25 degrees centigrade. Because the reaction are very I'll say sensible for the temperature and pressure, so take care about the temperature. That's why the protection of battery is very much important when we are talking about the application in electric vehicles, because at the very high speed, when the current is drawn from the battery that's little higher, so that create the resistance also, and that resistance increasing the temperature of the wire and entire circuit. So sometime to manage the temperature inside a system is a difficult task, especially in case of electronics. And hydrogen gas at 1 atmosphere pressure enter at the glass would bubbles over the platinum electrode, that is okay. And here H2 is what? 2H plus 2E plus ions. Now let us understand how it is taking a place. By the convention, the standard electrode potential of hydrogen electrode when the hydrogen gas passed at 1 atmospheric pressure, 1 atm, is bubbled through a solution of hydrogen ion of unit concentration in arbitrarily fixed at 0. We can see here hydrogen gas is what entering, and excess hydrogen gas is out from this side. And the reaction at because we are calculating the EMF with the help of Nernst equation, already you know about. So Nernst equation, so we can calculate the right hand side minus left hand side. Okay. Now depending on the half cell to which it is attached, hydrogen electrode can act as a cathode or an anode. Okay. And but in the given figure, hydrogen electrode is connected to the copper electrode, and it is act as anode here, because this one is what? Copper electrode. So this is what? Anode. H2 gas at 1 atm pressure it is entering here at 1 m of HCl, and this one is what? Again a salt bridge like a galvanic cell, and this is what? CuSO4 solution. Okay. And anode, at anode we know the oxidation is take place here, oxidation is take place at anode. Now, what are the calomel electrodes? The calomel electrode consists of a glass tube having two side tubes, and a small quantity of pure mercury is placed at the bottom of the vessel and is covered with the paste of Hg and Hg2, a Cl2. KCl solution is known concentration is filled through the side tube and right side of the vessel. The KCl solution is filled at the left side tube, which helps to make the concentration through a salt bridge, and that is very much important to maintain the concentration of salt bridge. And other electrode, which potential has to be determined. A PT wire is sealed into the glass tube. We will see in the figure how it is connected. You can see here calomel electrode. This is what called the PT wire, and this one is what the saturated KCl solution at this side, and Hd2Cl2 and Hg paste is here at this side, and here we are keeping the mercury one, and this one is what the salt bridge. The connection is from here to here, from the salt bridge. So at 25, the concentration is what? If we will increase the temperature, so concentration will decrease because of movement of ions and because of movement of molecules. So 1 m KCl H2Cl2 is what? It is at 0.33 volt, and it is 0.25 volt, and it is also 0.24 volt. And the corresponding electrode reaction is what? Hd2Cl2, that is what? Half oxidation and plus reduction. Means they are the half of reaction we are combined here, oxidation plus reduction. So Hd2Cl2 plus 2E is equal to 2Hd plus 2Cl. And what are the glass electrode? So this is what the ISE, the glass electrode, is one type of ion selective electrode, and it is made up of a glass tube ended with a small gas. Let us understand with the help of one example how it is working. First, let us understand this figure. Glass electrode diagram is there. So we have a reference solution of dilute hydrochloric acid. Means we can write it dilute HCl is there, solution is there here at this place, and at this one is what the black color wire, silver wire coated with the silver chloride, AgCl, Ag2Cl2 we can write, and this one is what the thin walled membrane. This outer membrane means cover, very outer side is what thin walled membrane is there. Now you can understand how it is. So both sides of the glass changed by the absorbed protons, and this change is responsible for the potential difference. And this potential is directly proportional to the pH difference between the solution in both sides of the glass. Glass electrode work in a pH range of 1 to 12. Okay, that means this is valid for the acidic and base both kind of solutions. And the electrode we can represent something like this. That means AgCl is converted to HCl, and glass is as plus, and AgCl act as a internal reference electrode. Now let's move ahead and try to understand how we will elaborate the Nernst equation. So this one is also very much important. So Nernst studied the theoretical relationship between electrode reaction and the corresponding cell EMF. Okay, and how they are writing small a capital A plus small b capital B is equal to CCD. So normally if you remember how we are finding the concentration of any solution, we are writing the equivalent A and into that is what the product divided by reactants. This is not like, we can write simply product, 1 minute, sorry, we can write here product, concentration of product divided by concentration of reactant simply. So Nernst had derived what? E net cell is what? E naught cell minus RT by NF, and ln C power C, you can write something like this, A power A and B power B. Okay, simply like this. E is equal to, I am writing here, E naught minus RT by NF and ln c power c, you can write something for the much clarity, d power d divided by a power a and b power b. This is what the Nernst equation is. It is useful to find the EMF of the solution. And if you are representing the same value in terms of log, in case ln, so you need to just multiply it by 2.303 in the above equation, and you can write RT by NF and log, and then that previous one values. Where R is what the gas constant, the value is 38.314 joule per Kelvin, and temperature is in Kelvin to 98 Kelvin, and this is what the farad. So 96,500, 1 farad is equal to 96,500 coulombs. And this entire equation, now after the keeping the values of RT, NF and this, so this entire value will be the like this term. So we can write 2.303 into 8.314 into 298, and now a divided value of this 96,500. So when you will solve, you will get the result of like this. Okay, so where we are using this can be used to the effect of electrolytic concentration on electrode potential. So if you want to like start the manufacturing of batteries, so this one is a very fundamental concept. So pH of the solution can be measured from the EMF and Nernst equation, also used for the finding of valency of an ion numbers. So this is very much usual. 3-4 functions are there. And let us understand what are the electrochemical series. When the metal are arranged in order of increasing reduction potential or decreasing oxidation potentials, and which are determined with respect to 1 molar of the solution, their ions, and measured on the hydrogen scale along the series or list, the result is called the electrochemical or galvanic series. So higher is the metal is in series, greater is the tendency to be oxidized, because metals are highly oxidized substances. Okay, so if oxidation will be there or metal will oxidize, that means corrosive tendency will be higher for metal and halogen, and relatively ease of oxidation or reduction can take place. So these are the disadvantage, I will say. C, standard reduction potential. This one is for reducing agents and this one is for the oxidizing agent. So lithium ion, why we are taking? Because the standard potential of lithium ion is higher comparable to the all. And this one is what the potassium ion is also there, which standard potential is slightly less than the lithium ion, but ever than the calcium. And sodium ion batteries are there whose potential is what? Plus 2.710 volt, which is absolutely fantastic. That's why sodium ion batteries are now in the market. Many electric vehicle manufacturer companies are using that one. So similarly, lot more things are there here, and in oxidizing agent you can see copper, silver, Hg and Cl2 are there. I am moving fast because so that you can understand the concept very clearly. Just kind of summary or revision to before entering into the big battlefield. You should just rehearse and keep practicing for that. Let us understand the batteries and fuel cell. And with the help of this, you can see this is what the Galvani Volta controversy here, Ligi Galvani, and this is what the Alexandro Volta and animal electricity, and the first battery, that is what voltaic pile. So first battery was made something like this, silver, this is what the paste bolt, and this one is what the zen. And who present? Volta presents his battery to Napoleon. Now you can understand it is somewhere 1800th century. So just before 200 24 years. The first electric motor built by the Michael Faraday, you can see here, and this one is a kind of vehicle, three-wheeler, and the first battery electric vehicle. Now this is a history. We should salute them, yaar. They created such a vehicle without any sufficient resources in 200 years back. So salute to them. They are the revolutionary for our technology and all. Okay. Now, gas battery, this is what the first fuel cell, 1839, very old. And Sir William Groove have designed this one. So we should not forget the history, because because of them we are today we are switching the mode of transportation from the IC engine to EV. And this is what the batteries of Nokia phone, everyone we have also used. And now let us understand what are the batteries. So the electrochemical cell connected in series, we have discussed previously. We discussed about the cells, and these are the cells. And if we are connecting these cells in series, suppose cell number 1, cell number 2, cell number 3, 4, 5, 6, and if we are connecting these cells in series, so this is called what? The battery. And this is not a matter of one row only. We are connecting like this and like this. Suppose 6 cells are this order and some cells are in this order. So connection of series and parallel I will explain with the help of calculation, but just know about. So batteries are storehouse of the electrical energy. So what energy is saving in the batteries? Okay. And they are primary cell and secondary cell. We all know about. Just I am taking the revision, quick revision. So primary batteries, these are called the non-rechargeable, and just use and throw, single use battery is there. And secondary voltaic cell, whose electrochemical reactions can be reversed by the current of the electrons running through the battery after discharge of an electrical current. So the secondary batteries can be restored to nearby the same voltage after a power discharge. So this was a kind of revolution. Okay, we can recharge the battery. And if you remember, हम लोग कितनी टीवी हमने देखा बैटरी को चार्ज कर before the electricity. So that was the kind of fun we had. And this is the 10th class question. What is the difference between the primary and secondary cells? So if you want, you can take a screenshot. I am not much interested to explaining it. And this is some examples of Lagrange cell and lithium cells, lead acid cells, nickel cadmium cells and all. Primary, secondary are both there, because the laptop battery cell is continuously rechargeable. We are recharging, we are charging it, using it, charging it, using it. And once it damaged, means damaged. The battery of torch currently we are getting, it is chargeable, rechargeable also, and also it is use and throw. And this one is what the representation of a primary cell you can see here. And this cell is reaction or the irreversible, means this one is what the cell reaction is there. And this is irreversible, means after discharging we cannot charge it. One reaction is happening for the charging of the cell, but reversible reaction is not possible. In opposite direction reaction, from left to right you are shifting from this side to this side, but you cannot shift from this side to this is what left to right, but you cannot shift from right to left, is not possible at all. So that's why. So at anode cathode, this is anode reaction, we have Zn2 plus 2 already we know about, and cathode reaction NH4 2NH4 plus and 2MnO2 plus 2 Mn2O3 plus 2NH3 and H2O. And the cell reaction we can combine this to get this the cell reaction. And lead storage battery, this is what called the lead acid batteries also. And if you remember, these are still very much popular for the some applications. And this is also working on the same cell principle. Why I explained the very small thing, why we gone through with the way for the very small thing, so that we can understand this one easily. Now this we can understand half reaction is there, half reaction is there, and cell reaction is there, and we don't feel any kind of problem. Doesn't matter what kind of battery it is, lithium ion or lead acid batteries, but the cell reaction will take place each and every battery. So that's why it is important to remember it sometime. So anode Pb plus HSO4 plus PbSO4, this is lead sulfate. Hydrogen ion plus 2 electron is what? Moving from one side to another side. And at cathode, this 2 electron is depositing here. And because the movement of this electron is creating the electricity. That is what we need to understand. And again, this is what lead sulfate and water is there. Okay. And lead acid recharging, see, first very low self discharge, means if we are keeping the battery at a rest for some time, so discharge rate, self discharge rate is less. 40% in 1 year, 3 months for nickel cadmium batteries, and it don't have any kind of memory, data storage is not possible, cannot be stored when discharged. The problem is there. And limited mean dead kind of, and limited number of full discharge. And suppose if you are purchasing the new battery, you are charging it 1 time, 2 time, 3 time, 5 time, means sometime it is 100 time, 200 and 500. There is a limited number of charging of these batteries. We need to understand danger of overheating during the charging, and there is a, because of chemistry, continuous cell reactions, there is a chances to the overheat of this battery. And application we are using in automobile and construction equipment, and stem for the backup of system for engine batteries, and in our motorcycles, in 2-wheeler, 3-wheeler, just for the starter purpose of the thing, to rotate the motor. For the crankshaft we are using that batteries. What are the advantages? We will say the low cost, low life cycle, ability to withstand mistreatment sometimes, and perform well at high and low temperature. Because the EV range, I will say the 25 degrees is the ideal temperature for electric vehicles, and maximum you can go for the 65 degrees centigrade, but at this temperature the performance of vehicle will reduce, means the life cycle of the battery or controllers will decrease. Okay, if we are operating beyond that. So this temperature is what? This temperature is very less. If you are driving the vehicle at in Rajasthan, and parallelly someone is driving vehicle at Kashmir, so there are two different conditions are there. If same vehicle you are operating here and here, so you will not get the much performance in these states of this country. But parallelly, if you are operating at any state which is stable between the 25-35 degrees centigrade, so that is the best atmosphere for the electric vehicle, I'll say. And lithium ion batteries, what are the lithium ion batteries? Lithium ion batteries are basically the secondary batteries, consist of anode of lithium and dissolve as the ions into the carbon, and the cathode material is made up of from the lithium liberating compounds. And typically the 3 electroactive oxide material: lithium cobalt oxide, lithium magnesium oxide, manganese oxide, and lithium nickel oxide. This is what the electrode materials are there. So lithium ion batteries are currently very much popular, and India is now got the reserve of lithium in Rajasthan and Jammu Kashmir and some portion of, I think, Himachal Pradesh. So huge amount of lithium is there, and let us hope for the best. The expense of the battery should decrease by certain amount, so that the cost of electric vehicle should be less. As in first lecture I discussed, there is a difference of 7-8 lakhs rupees for the same kind of electric vehicle and gasoline vehicle or IC engine powered vehicle. So if we are able to reduce that difference, so the acceptability from the customers will increase. So that what the all companies are trying to do currently, because we are importing the lithium ion battery manufacturer is there, India assembler is there, but we are exporting the cells from the Australia and I think USA. And today, during the charge and discharge process, lithium ion is inserted or extracted from the interstitial space between the atomic layers with the active material of the battery. Simply, the lithium ion is transferred between anode and cathode through the lithium electrolyte. So, and neither the anode nor the cathode material essentially change, and the operation is safer than that of a lithium metal batteries. If the metal will change, so that will not be the mode of safe operation. And the chemical reaction that takes inside the battery as follows during the charge and discharge operation, because this works on the reversible reversible of the reactions because of C. So we have this one is the discharge, a lithium and lithium ions, and negative lithium ion, and this is positive LiCO2 lithium ion electrode. This is a very simple structure you can understand. So ions is there between the plates. What are the advantage of lithium ion batteries? So they have high energy density. What does it mean? Per unit volume, this is producing a high energy in comparison to any other batteries. So that's why we are preferring it. High energy density means lot thing for the electric vehicle, and it maintains the low weight. Even they produce high voltage, about 4 volt, as compared with the other batteries. Already we compared it with some other batteries, right? And they have improved safety, more resistance to the over voltage. The protection is high in this lithium ion batteries, and because we are not using any no electrolyte, means they are immune from the leaking. So leakage problem is not there with the batteries. So that means transportation is easy for them. And charging and discharge, fast charge and discharge rate, we can, if required, we can discharge it quickly. And fast charging is infrastructure and technology is currently developing, or some where it is developed, we can charge our vehicle in half an hour and 1 hour. And many companies are claiming to charge it in 15-20 minutes, and it is currently out of my experience, but when I will go through, definitely I will explain for you also. What are the disadvantages? They are absolutely, they are expensive, and they are not available in standard cell types. The two problems are major there, we can understand. And lithium ion batteries used in cameras also, calculators, we can write here, mobiles and laptops. Many places are there where we are using these lithium ion batteries. They are very popular, and they used in cardiac pacemaker and other implantable device, sorry. And they are used in telecommunication equipment, instruments, portable radios, TVs, pagers. अभी पेजर की याद आती है तो हिजबुल्ला वालों की याद आ जाती है कि नहीं? बेचारे सब फट गए थे उधर पेजर उनके, and because of this lithium batteries can be controlled from outside also. Okay, they are used to operate laptop computers, already I mentioned here. Flow of batteries, this is what the anode, negative sign is there, cathode, positive sign is there, and molten, it is what, Na2CO3, and this one is what, porous carbon, and an electrode containing Ni and NiO. Hot O2 gas is coming from this side, and this one is what, the H2 is coming from here. This is porous carbon electrode containing this one is what, Ni, and the hot H2O gas is what, leaving from this side. Now we can just take a glance at the fuel cells, exactly what they are. We will discuss in detail if required in hydrogen fuel cell section. So the cell that converts energy of combustion of fuel like hydrogen, methane to electrical energy. So fuels are usually gas or liquid with oxygen as the oxidant. Different fuels are the direct conversion of chemical energy to the electrical energy has 100%. And the cell representation, how we are representing fuel, electrode, electrolyte, electrode like, and something. And what are the types of fluid? We have oxygen fuel cell and we have oxygen. One is what? Hydrogen. Another one is what? Methanol. Because the efficiency of this one is very much higher in comparison to methanol oxygen fuel cell, so that's why industries and some company vehicle manufacturers are want to go with this. I in previous video I told you that Toyota Mirai and Honda Clarity something, and they are working on this hydrogen oxygen fuel cell. Okay, so what are the limitation of large weight and volume of hydrogen gas fuel storage system? Because it is not perfectly developed, so that's why the weight and the volume of the complete setup is very much high, and it's difficult to accommodate in a car system sometimes. And if we are doing, the weight of a car is what, very high in comparison to the conventional vehicle or electric vehicles. So high cost of hydrogen gas, the process of separation of hydrogen from water or from somewhere is not a easy task. So separation process of pure hydrogen cylinders are costing high, and we should bring the cost down. Lack of infrastructure for distribution and marketing of hydrogen gas. Even in developing countries, you will not find a single store for the hydrogen gas, even that is open for the public. And most basic fuel cells suffer from the carbon dioxide leakage. That is also very much important. Okay, so we have many types of hydrogen, oxygen and alkaline fuel cells are there here, and but we are not going to do it right now. And in one lecture of I will do with the complete hydrogen fuel cell, how it is working. Like currently it is not required, working of this complete geometry, complete setup, how it is working, what is the role of these oxygen balls or hydrogen balls here, how it is everything is happening. So I will explain in other videos. So let us make a quick note for the third lecture, what we are going to do. So in our third lecture, we will do, in third lecture definitely we will do what? We will do the battery pack modeling. We will do battery pack modeling. That means we will prepare the complete battery here, and I will show you the battery pack. We have here one battery pack also. I will show you, just a minute. I will show you the one battery pack which is here. You can see here. So this is the battery pack, just for the purpose of this. So we will understand how we are connecting this one in series and how it is connected in parallel. Series and parallel combination is there for batteries. So definitely we will go through with this. I will teach you how to do this, and obviously the application of BMS along with this battery, how we are going to connect the BMS system here. And then after we will learn how we can keep the safe of our batteries. So battery pack modeling and some parameters like SOC, SOH, and we will go for the charge rate, C rate, we are calling it C rate. A lot more things are there to understand. And also we will go for the safety parameters, कि हम लोग अपनी बैटरी को किस तरीके से और कितना सेफ रख सकते हैं. दिस इज ऑल्सो वेरी मच इम्पॉर्टेंट. एज ए यूजर यू शुड बी स्मार्ट, एज एन इंजीनियर be the smarter and be the smartest. So it is important each and every topic for us in order to understand the complete course. So friends, if you like this video, you can share it with your friend, and if you have any questions, any suggestions, use the comment box, and thank you so much for watching the video. We will meet in third lecture. Okay, bye bye, see you.